So, as usual, we will start with Rakuten and Rakuten Symphony overview, and we'll discuss what Rakuten is doing for the Open RAN and what is our solution for management or ONM that we can uh, provide to the world for better management of ORAN systems. So I categorize this session based on three agenda. First, we'll start with the Rakuten overview because I don't know how many audiences who have already attended the previous sessions. So for the new audience, it would be great to know what Rakuten is doing and a little bit history about the Rakuten. And then we will start with the Open RAN overview. So I will show you what traditional you might have working with the traditional network. So I'll try to distinguish the differences between Open RAN and the traditional RAN, so that you can easily mark the dotted line and you can understand the differences or the modern network what you can get from it. So that we are going to discuss in the overview in management session. I will tell you uh, what what tool or what functionality we are offering for management of open end devices, that including the RAN network, the cloud network, the core network, and the all other IPTX and hardwares. So all these can be managed through our management solution that we are going to discuss here and how it will function. I will also give you some brief on that. So let's begin. So this is a Rakuten ecosystem, and Rakuten has been successfully executing the ecosystem strategy for over 20 years, and it has 1.6 billion of global membership. It present in more than 30 plus countries, and it has businesses more than 70 plus. Mainly, they're dealing. They're working on mobile e-commerce, card payments, banking, security, insurance, sport and culture, ads and media, digital content, life and leisure. So these are the main segment where they are working, and they have the different companies on different segments. For example, for mobile, this is the part of communication pillar, the communication segment. And in communication, they have three part: mobile, e-commerce, and card payment. And in mobile, we have two companies. Even you can call it as three companies. One is Rakuten Viber and Rakuten Mobile, which is a operator in Japan, and third one is Rakuten Symphony. So I will tell you what Rakuten Symphony is doing apart from this Rakuten Mobile and other businesses in a moment. So these are the Rakuten at a glance. The presence geographically, it shows that we are the global company, and we are having the offices and presence in multiple regions, multiple continent, and countries. And uh, this is how the presence make us more reliable and more uh, 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 scalable solution, and an available solution for the customers and for the enterprises, because we have the presence in most of the regions, right? So this is a vision of our chairman and CEO, Miki Mikitani. They want to empower the people to realize their dreams. And for especially for Rakuten Symphony, they have the hope. Uh, and in some of species, they say that uh, internet is not a service or leisure. It's a necessity, because people have to get the internet to work or to connect to their love, connect to the people, or connect to the loved ones. So this is a necessity, and that we need to and that we need to empower the people so that they can realize their dream. All right, let's go with the Rakuten overview. And as I told you, in communication and mobile part, we have two companies, mainly the Rakuten Symphony and Rakuten Mobile. So mobile is a uh, world first fully virtualized cloud native mobile operator in Japan, and these are based on fully open RAN. They have around 300 plus cells on 4G and 5G, along with the small cell, femtocell, and pentocell, and that all is open RAN. So it's the biggest deployment of open RAN in the world. So Rakuten Symphony is actually selling the idea what we learned in the Rakuten Mobile and what we deployed in Rakuten Mobile to the world. So whatever experience we are having here in Rakuten Mobile, we wanted to leverage that experience to the world, to the telcos, to the enterprises, so that they can easily build their secure and open network. Let's start with the next topic. Next agenda. This is open and overview. I hope I'm not going too much fast and people can hear me easily. Okay, let's start with, as I told you, I will tell you the simple difference between the traditional RAN and open RAN, so that if you are working in traditional RAN, you can uh, easily understand that what difference is there from traditional to open RAN, and then you can match the dotted lines. Okay. So for traditional RAN, radios which you are deploying on the site is a proprietary. You cannot use any other vendor radios with the other equipments. For example, the baseband or CUDU or other infra. It's a proprietary. So if you are you are working for a traditional RAN vendor, or for a company who is dealing with this, you can easily understand the same company is providing the radio, who is providing the baseband unit, and other stuff. The CIPRI, the interface, the frontal interface, what they're using is CIPRI, and this is a proprietary. They have their own codes which can communicate to baseband from the radios. Okay, so no other integration, third-party integration is possible. Now let's talk about the baseband unit. So baseband is not splitted. All the protocols, layer 3, layer 2, and part of layer 1 is there in the baseband, and it's not splitted. So they have very less opportunity for resource pooling. Okay, because this baseband has to be installed in one site, and it's not a cloud. So the cloud native uh, functionality or benefit is also we cannot leverage from the traditional RAN, and the info what they're providing is insufficient. So these are traditional RAN, and for open RAN, uh, first of all, we are using any third-party radios who is ORAN compliant. So we have the multi-vendor operability with Open RAN. The interface, frontal interface from radio to baseband is eCPRI, what we are using. It's an open interface. Okay, it allows us to integrate any radios or any baseband vendor to operate for a customer. Now for baseband unit, we have the split, the 3GP, as per the 3GP split. We can have the DU and CU nodes, uh, which can be deployed based on the customer requirement centrally in one of the centralized data center, or it can be in some edge data center nearby the sites. But what we can leverage is, since this is a cloud, it's working on the cloud, and deployment is centralized. So we can have those leverage of cloud native along with the centralization. So we can pool the resources from the baseband in the Open RAN. Okay. And also, as I told you, multi-vendor operability is possible because you can use any video from any company. Okay. Now the next is CAS hardware. So the RAN vendor, Open RAN vendor, don't need to bring their own hardwares. This hardware is from any vendor. What we want is it should be the COTS based hardware. Okay. And if it's fulfilling the requirement that is a cost based hardware, then we can host our network functions onto this. Okay, first we virtualize this through the cloud, available cloud options, and then we can host our network functions. So what it giving us is multi-vendor operability, open interface, vendor locking. It's removing the vendor locking when the operators no need to rely on one vendor uh, to enhance or to scale in or scale out their network. They have the multiple option. They can have better negotiation with the customer or with the vendors due to this. Now, if we talk about the Rakuten Symphony products and services, this is what we are offering to the world. That is what we learn in the Rakuten mobile and offering to the world. So we have different pillars uh, of services, and started from the unified cloud. Okay, as I told you, we don't offer hardwares. So hardwares could be a COTS based hardware. It could be from any vendor. It could be from let me give you some example. It could be from Dell. It could be from HP. It could be from Supermicro. It could be from any other COTS based vendors. Okay. Now, software wise, what we'll do is we'll host our uh, cloud architecture onto the hardware. Okay, so for the cloud we have our Rakuten cloud, which is earlier it was Robin cloud. Now Rakuten acquired the Robin. Now it become the Rakuten cloud, unified cloud. So we will host the Rakuten cloud onto that third party hardware. Once cloud is hosted, the hardware would be virtualized. Okay, now that hardware, instead of using for one functionality, it can be used for multiple functionalities. Okay, once it is virtualized, now we can host our network functions. So it could be CUDU RAN functionalities, it could be any Mac functionalities, any core functionality, or RIC functionalities. So anything can be hosted. Uh, Apart from this, the topic of today is the management. So management can be also hosted on the same server after the virtualization. So these network functions can be hosted on the same server based on the resource requirement. Now, once now you have the hardware, you have the cloud. Now your hardware is virtualized. You hosted your network functions, your CUDU, your RAN, your core, your Mac application, your RIC, everything is hosted. Your SIM or management nodes. Now, what you need to do is you need to manage those network. Okay, so this is a today topic. So to manage those network functions, we have intelligent operation OSS, which is in Rakuten we call it as SIM. Okay, SIM or SIMOps. So we have the modern OSs, NMS and EMS for intelligent operation and the automation. And the so if I'll tell you what difference we have from the OSs which other vendors have, and what Rakuten is having is we have the intelligent operation OSS system which provide the full-fledged automation for for the network functions or for the applications. Even for integration of site or commissioning of site, you don't need to send any people on the site. It can be automated or power on air automatically from your NOC. So it's a full automation providing the zero touch provisioning functionality along with based on the AI ML. It's also predicting the fault on other errors and correcting based on the historical data. So this what we are leveraging and uh, uh, together collecting as an intelligent operation system which is managing all the nodes. On top of that, we also have digital experience where we can provide the OEMs with the or customer provide the customer with the BSAs and digital marketplace services. And we also have the internet and ecosystem services where we can provide the membership platform for the operators, for the customers. We can provide the loyalty platforms, and there are multiple ecosystem as well on the internet side that we can also provide. Along with that, to manage all this thing, we have the end-to-end services uh, business unit who manage all the functionalities or the functions of Rakuten SIM world. Okay, so if I'll tell you based on the previous description, I told you we have the RAN part. So our focus should be on the RAN because we're talking about the Open RAN. Now, if someone is having question that if your architecture have the split, you don't have BBU anymore because it's not a traditional network. We have the split architecture. Split means the BBU has been divided in two part, DU and CU. So what interfaces you have between all those things and how what latency requirement or what bandwidth requirement you do have uh, that can be shared with the people or with the customer. So there's a front haul. Front haul means from RRU or ORU. RRU is a in traditional RAN, you can call it as RRU, but in Open RAN, it's ORU, Open Radio Unit. So ORU is hosted on the site along with the antenna. And if someone has had attended my previous sessions on ORA, so you can understand. I told you that we have very less footprint on the site, and that also saving the costs for the operators because they don't need to rent the site for too many equipments. So there would be a radio and the antenna, just radio and antenna. If battery is required, then batteries and rectifiers. No other technical equipments on the site. Everything is centralized. So DU will be on the server in the data center. It can be in a remote data center or it can be in is data center. And the interface between DU and ORU is called front haul. So what latency is required is for 4G we are requiring 100 millisecond, less than 100 millisecond latency between this. And for 5G as well, for sub 6, it's 100 less than 100 microsecond, not millisecond, sorry, microsecond. Less than 100 microsecond for 4G and 5G. Okay, this is one way. For two-way, multiply by 2, right? 200 millisecond microsecond. Now, why this is important? This is important because it tell you that what distance you can have from RU to video. So roughly, it depend on multiple factors, but roughly, if I'll calculate and based on my experience, I can tell you the distance from RU to VDU. It can be 30 kilometer, 40 kilometer, or more than 40 kilometer based on uh, your transport capability. Okay, so distance could be more from RU to DU, and from DU to VCU it could be even more because for mid haul the latency is more than 25 millisecond. Okay, it's a one way. Okay, 25 millisecond means RTT is 50 millisecond. So the distance from this and this could be even more than 100 kilometer. So you can understand the VCU node could be in one location in one country, and for small countries, and you can have distributed DUs and the RU could be on the main location on the main site. And what is the advantage of keeping this CU on centralized location or DU on the centralized location? Because this CU can connect it with multiple DU, and that is how one server can be used for multiple node Bs. All right. So our node B is not this is not the one node B for us. This can be many node B for us. All right. It's not a traditional network. For traditional, one BB on the side means one node B. But for us, it can be many node B. It's based on the resource requirement and then the functionality requirement asked by the customer. So what I can tell you is this is the advantage of keeping the CUs on the centralized location. We can pull the resources for other node Bs, and one server can be used for many node Bs. On rough example, one server for the CU can be used for 9 node Bs in a standard calculations. Okay, so you can understand one server, 9 node Bs. And for DU as well, one server can be can host more than uh, in the minimum requirement can be 9 to 10 DUs it can host. Okay. All right, so along with that, bandwidth requirement is also mentioned here. Let's go to the next part and let's see what we have. Next part is just wanted to show you the momentum of Rakuten Symphony in ORAN technology. So these are location we are doing we are having the commercial deployment along with in some of the location we are also doing the PUC and the lab for different customer in different region. You can see all the regions have been covered with the Rakuten ORAN system. Uh, and it's deployed in many regions, including I told you just now that RMI full-fledged commercial deployment in Germany. 1&1 is a full-fledged commercial deployment is happening, and we also have in India Airtel, and in Germany, sorry, in Italy it's a TIM. So there are many more with the POC and lab in Africa region, in MEA region, in the US, in Canada, and in Latin America. So this is just a momentum. Just want to show you so that you can understand what Rakuten is contributing for the Open RAN and what Rakuten is doing. Now the deployment or the scenario what I explained you can be based on the different use cases. So our network has been deployed for 4G brownfield and 5G NSA along with the greenfield operators. Okay, we also deployed in some of the location 5G standalone network. Okay, the uh, although that can be benefited for brownfield as well as greenfield operator, but we have deployed for the greenfield. And we also deployed our private network. It's a very compact solution which can be fit in one box, one box which have all the BBU or CUD unit along with the core, along with the management solution, and there will be just one radio or one ORU on the site. Okay, so the private network solution is also happening for the Rakuten Symphony, and we also have option or use cases for the multi-tenancy. It means from single location you can manage multiple countries operators. Okay, so this can be use cases for the operator or the group who is having multiple opcos in different countries. So that group headquarter can manage all the opcos network functions from one location. So this is called multi-tenancy, and it can be for multi-country or it can be for one country as well. For one country, if operator is having agreement or roaming agreement with different, uh, not roaming agreement actually, if they have the different operators. I mean, in other words, they can say, you can say that they have purchased multiple operators. Let me tell you the example of India. So earlier there was two different operator, Vodafone and Idea. Now they have merged. So now they are one company. So this multi-tenancy can be useful from one location, instead of having two different knock for different Voda and Idea. They can have one knock and they can manage both from one location. So it can be also used for in-country solution, and for multiple country one location. It can also be useful. Now for the next one is management for Open RAN. So uh, let's go to the next part. Uh, so this is the if you remember, I told you in pillars of Rakuten Symphony and the functionality what we are offering. I started with the unified cloud, that we have the cloud. Once cloud is deployed or hosted on the hardware, we can host our network functions, and then network functions can be managed through our intelligent OSS, or intelligent operation system. So in management through SimWorld, what we are providing, this is what I try to mention here. So this is SimCloud. Okay. Again, to host SimWorld, we require the SimCloud. It's also cloud native. Okay. So cloud native have their own benefit and other automation uh, benefits that we can again leverage for the sim world along with the open RAN. So these are different we are talking, not the open RAN. So these are management solution, right? So what we are providing is multiple functionality like Simplan, Symbol, SimOps, SimCare, and SimMax. So Simplan is basically a network planning app suite, which is essential for network planning capabilities, and it advanced network planning and capabilities. Okay. So when if you need, if you require to plan your network, not the manual, in automated way, then the Simplan can be best uh, app suite for you, because it provide the network planning capability uh, in automated way. The next functionality is Symbol, which is for network building and deploying AppSuite. So for deployment of the sites and building network with the different equipments, this Symbol can be a application or tool that can be useful. Okay. So why I'm telling you different network functions, because you might have heard only one OSS network system for management, if you're not aware about the Rakuten application, or in a whole in ORAN, whoever is following full-fledged automation, there is no one application that can be that can managing everything. We have multiple applications for each and every requirement. Likewise, for network planning, I told you network, we have the Simplan. For building network, we have the SimBuild. This is for essential project and site management capability. If you want to do the any AT on the site, or any dispatch the material, anything, the deployment, that it assists the engineer to do their work, and everything is automated. Each and everything is connected to each other. So this is what we can get from Symbuild. Now the SimOps is the operation app suite. So once your site is deployed, you have to operate that. So for operator, we have the SimOps. So for all the network operation capability that we can leverage this SimOps suite. So mainly your day-to-day operation can be managed, like your FM, PM, and CM. Your observability management, your other functionality can be done through this CMOps. Okay. You want to see the KPIs. It could be from the performance management. It's a part of SIMOps. You want to see the fault management, the faults of the network. It can be through SIMOps. You want to configure something from day zero or day two or day three, means the initial configuration or later fine tuning. That should be done through the SIMOps. The next application what we are offering through SimWorld is SimCare. So this is a customer support app. Now, if the customer wanted to manage their network through customer care, okay, your users must have some complaint regarding maybe the coverage or quality or anything. So we are also providing the same care for the customer care support. There they can get some basic information of the network, that customer care executive people. They can get some basic informations, and they can also share the feedback to the technical team directly from SimCare. So no need to send the email to the from the customer care to the technical team, and then will get response, or someone forget the email, then there will be complaint to complain, and people and your user or your customer will be frustrated or irritated if they're not getting solve their problem. So we have automated this. It will be directly connected with the other applications, and if something is they have get in the customer support, it will directly communicated through app to the technical people, and their response also will be marked, and it again go back to the SimCare platform for the customer support people. Because if that user is calling back to get the feedback whether their problem is resolved or not, so this portal will have the solution what they have done. All right. Next is Simax. It's a monetization app. So for basis, we have the Simax that will provide for the billing and other stuff. So this is the on nutshell. This is the operation modules what we have, and these are the part of Symbol. Now, if I'll tell you the value what we are offering to the customer or to the people, that we are providing the harmonized management component that are hardened across the customer and the use cases for better support, and we are offering fully cloud native and microservices architecture that scales well. I told you, our along with the ORAN network functions, our management is also cloud native. So you can have the microservice network architecture that is again have their own benefit of microservices architecture, right? There will be uh, a greater availability, greater scalability uh, through the microservices, and you have the automation as well, right? You can scale whenever is required, scale in and scale out. So that is a advantage you will get from the cloud native. We are also offering NBI northbound interface and SPI southbound interface framework that support cloud native and the customer integration. So if some operator is having their own umbrella OSs, we can we can mm, we can interface or northbound our SIMOP solution to their OSs, so that their people can manage from their OSs, but the KPI or the information what they will get is very detailed, very elaborative, and very in automated way. But they can manage from their own OSs. Also, we are providing the best UI for the Symbol, and best deployment features is easy access to fast growing set of Symbol features and engage the network functions in the future. This is future proven. Now, let me tell you a simplified setup for small enterprises, and or you can take this example for the telco grid network as well. So, how our architects look like for the SIMOps or for the network monitoring? Okay, So these are cards hardware. Okay, these are simple COTS based hardware. We have the Kubernetes platform, cloud virtualization from the Rakuten cloud. Now we have hosted our logical apps, this 4G CU, 5G CU, 4G DU, 5G DU, small cells, core, or other Mac applications, along with this SIMOPS here. Okay. Now, so you can see same server is hosting all the applications. You don't need separate server for each applications. Same server can be used to host all the applications, irrespective of your applications. Anything can be hosted. Apart from this, any third party applications can also be hosted on the same server along with our logical apps. Each one have their internal interfaces. I just keep here so that it can be a little bit in elaborative way, and I can explain other functionality. Otherwise, it can be fit here. Okay, and it has their own interface connecting each modules. So in SIMOPS, we are providing FM, fault management, performance management, configuration management, this observatory framework, and inventory management. Okay, uh, this has been connected through telemetry for FMPM and inventory. We are using REST APIs for configuration management. So anything you can push from here to net functions. You want to change one KPI, if it's not working fine, then you can push from your network manager to the network functions or logical apps. You want to see any FMPM KPI or inventory KPIs, you can ask network functions to provide this through your PM functionalities. Okay, so this is how to and from function is performing for CM. You are pushing the functions to the towards the logical apps or network functions. And if you want to get something, the fault data or performance data or inventory data, then you are asking net functions to provide this through ORAN CMOPS network monitoring tool or SIMWorld. All right. I hope I'm clear with this architecture, simplified architecture, and you are now getting how it can be, how the management of ORAN working with the logical apps and then the cloud virtualization. So this network monitoring is not only monitoring the logical labs, it's monitoring the Kubernetes platform. It's also monitoring the COTS server. Okay, so it not just monitoring this and this. It's logical labs. It's monitoring Robin, IO, or Rakuten cloud platform as well as COTS hardware. Okay, so this is the advantage of the management solution what Rakuten is providing. And if we talk about the main features, what we have for CM, configuration management, fault management, and performance management. So I don't know how many of you are aware about the day one and day two configuration. So basically, uh, these are the so there are three day zero configurations. We usually call it in Open RAN: day zero, day one, and day two. So day one and day two is mainly day zero is a very initial parameter which is required for a site. Day one is mainly uh, so for example, day zero is the IP address of the site, the DNS host IP address, and all other equipment's IPs. So it's day zero. Day one is the configuration data. Okay, like what is the uh, uh, what is the initial KPI or golden parameter you want to configure for the site, and other stuff as well. So that is a part of day one. And day two is mainly the fine tuning. uh, for example, you configure the golden parameter and you set the threshold that the handover would be happen if the if the RX level gap from one site to two site is 5 dBm, but you saw that the handover is stretching and you are getting handover failed. Now you want to optimize the site. So what you do? You will change the D2 parameter. So the fine tuning can be done through D2 parameters. So this is a simple. This is a example I can give you to explain what D2, D1, and D0 is. So auto commissioning we are providing for the configuration management. Auto commissioning means you don't need to uh, involve too many people for the configuration and commissioning. It's automated. We are providing zero touch provisioning, so auto commissioning can be done. And if you remember in one of the session for network planning, I told you what resource, how many resource we are actually saving, manpower we are saving through this automation. It's a one third actually. Okay, we are also doing the ANR automatic never relation through configuration management, subscriber traces, and the control operation of sudo, cell lock, unlock, restart can be done. So these are main features. It's not only feature. I'm just highlighting some of the features. There are many more, right? So don't confuse with that. That this is the only feature we are supporting the CM. There are many more. I just highlighted some of them here. For FM, alarm management, the alarm correlation, actions, the outage detection, alarm history, incident management, and ticketing is some of the example of fault management feature. For performance management, as usual, KPI generation and aggregation is an essential part of performance management. We are also having the KPI builder, so you can configure your own KPIs, and based on that, your network will work. Okay, let's say that there must be some list of KPI, but you are observing that in some of the clusters, some of the sites is not behaving good in certain time on certain day, or not day, certain time. You can make a customized KPIs through KPI builder, and you can monitor that. Reporting and dashboard you are also getting from this performance management. Threshold management, you can change the threshold. You will be getting from this performance management feature. Alerting, if something is getting passing the threshold, then you will get the alert. Okay, so these are the main features, not the only. We are having from this configuration management, fault management, and performance management. Okay, so this is all we have from today's management of ORAN session.